All right, for rational expressions, now we're going to take a look at adding and subtracting fractions in one video. So we're going to take a look at the rules of adding and subtracting fractions, and then we're going to take a look at some examples of doing so. All right, so here are the rules. We have two. We have one for adding and one for subtracting, but you'll notice that in order to be able to add or subtract fractions, we have to have a common denominator. So the denominators have to be the same to add them. And what you do is when you have a common denominator, you keep the denominator and then you either add or you subtract the denominators. So they're the same, keep the denominator, and then we subtract the numerators in this second part here. So what we're going to notice in example 1 is we do have a double sign here. We're going to change that to a single sign. We have 2 over 9. When the double signs do not match, we're going to change that to a subtraction. So now we have a common denominator of 9, so we subtract the numerators and we keep the denominator. So this is equal to negative 3 over 9, and then this reduces to be negative 1/3. Now the calculator will take care of that automatically for you, but that's how you do it by hand. Let's take a look at example number 2. We already have a common denominator, so when you have your common denominator, you keep it and you subtract the numerators. So 6 minus 3 is 3, and then we keep the 7. So this answer is 3/7. What about in example 3? Once again, we have a double sign here, and the double signs, they match, so we're going to change this to be an addition problem. Now you notice that we're trying to add fractions that have different denominators. So when they have different denominators, what you want to do is find a common denominator. So when I'm looking at 5 and 6, we're looking for a number that they divide into evenly. So what do 5 and 6 divide into evenly? Well, that answer is going to be 30. So here's what we're going to do. Write down the 30. Now this is the concept that we talked about earlier. It's the concept of equivalent fractions. So off to the side, let's do this. 4 over 5. We want to rewrite this so that it's equivalent to a new fraction that has a denominator of 30. So how do you make 5 become 30? You have to multiply by 6. Therefore, we have to multiply the top by 6. That gives us 24. So what we're saying here is 4/5 is equivalent to 24/30. They look different, but they have the same value. They are called equivalent fractions. Likewise, the 1/6. We want 30 as our denominator. So 6 goes into 30 5 times. Then we have to multiply the top 1 here that you see by 5, which is also 5. So 1/6 is equivalent to 5/30. So when we add 24/30 to 5/30, that's going to give us a total of 29/30. Once again, we keep the common denominator and we add the numerator. So 24 plus 5 is 29. Now what I want to do is just take a minute and show you what I would call a vertical method of doing this. So let me just erase this again. It's doing the same problem, but just a slightly different way. It's vertically instead of horizontally. So we have 4/5. We want to add 1/6. So by looking at these, we know the common denominator is going to be 30. So here's what's truly going on here. We're multiplying 6 by 5. That gives us 30. The rule is if we multiply the bottom by 6, we have to multiply if we multiply the bottom by 5, we have to multiply the top by 5. If you look at 5 over 5, that's equal to 1. So we're just multiplying 1/6 by 1. It's just that 1 looks a little bit different. So 5 times 1 is 5. Likewise, for the top fraction, we need to multiply the 5 by 6 to give us 30. If we multiply the bottom by 6, we have to multiply the top also by 6. Once again, 6 over 6 is equal to 1. So 1 times 4/5 is still 4/5. It's just that 4/5 now looks different. So 6 times 4 is 24. So you can see now that we have a common denominator. I'm running out of room here at the bottom of my screen. So 24/30 plus 5 more 30ths is a total of 29 30ths. So let's go ahead and practice a couple more. In example 4, we do not have a common denominator, so we have to find it. So let's write it like this. So we're looking for the smallest number that 9 and 3 divide into evenly, and that's going to be 9. So we have negative 7 over 9. So the top fraction, or the first fraction, was actually already okay. It already had the LCD, which is 9. We need to make the second one have a 9. So what we have to do then is multiply by 3 on top and bottom. So 3 times the 2 gives us 6. And don't forget, this is a subtraction problem. So that leaves us with negative 7 minus 6. We keep the common denominator, and then we subtract on top. So negative 7 minus 6, be careful, the same sign. So we add them, and we keep the common denominator. So example number 5. Go ahead and change the color a little bit here. We have 2 over 7. And we have a double sign that do not match, so that becomes a subtraction. And then this is 9 over 14. So what's the LCD of 7 and 14? It's 14. So this second fraction already has it. We need to make sure that first fraction gets it. So we have to multiply the first fraction by 2 over 2. 2 times 7 gives us the 14. 2 times the 2 gives us 4. So 2/7 is equivalent to 4/14. Now we're going to do the subtraction. We have 4 minus 9 over, keeping the common denominator 14. That gives us negative 5/14. So you'll notice in number 6 that we have a few fractions that we want to add and subtract up here, and we have several double signs that we also need to take care of as well. So let's say that you look at these denominators and you have no idea what the LCD is going to be. Here's a method that will help you find it. Let's just write down the denominators, 9, 3, and 6. This is called the repeated division method, and what we're doing is looking for numbers that will divide into the numbers in this row here. For example, let's start with 2. Does 2 divide into any of these numbers? And the answer is yes. 2 divides into 6 3 times. But 2 doesn't divide into 9 evenly. We're just going to bring that down. Nor does it divide into 3 evenly. We just bring that down. So now we want to divide again. Is there a number that will divide into any of these numbers evenly? Yeah, 3. 3 divides into 9 3 times. 3 divides into 3 once. 3 divides into the other 3 one time. The columns that have 1s in them are now done. So when you get a 1, you're done with those columns. Can we divide again? Yes, use 3 one more time. 3 divides into 3 one time. Now all 3 columns are done. So we can clearly find now the LCD is in the problem is over here. If we just multiply these numbers that we used to divide, 2 times 3 is 6, times 3 is 18. The LCD of 9, 3, and 6 is 18. So my screen jumped on me there real quick, so I fixed it. LCD, we just said, is 18. Once again, it came from multiplying these numbers on the side. So what we want to do, let's get rid of these double signs. We have negative 5/9. The double signs here do not match, so we're going to change that to a minus. 2/3. They do match, so we change that to an addition like this. We're going to go ahead and work this one horizontally here. We know the LCD is 18. So we want to write all of these equivalent fractions that we see here. So here's what we do. Simply divide. 9 divides into 18 twice. So then we have to double the 9 or the 5, which becomes 10. 3 divides into 18 6 times. 6 times the 2 is 12. 6 divides into 18 3 times. 3 times the 1 is 3. So the second row that we're looking at here, these are called equivalent fractions. 10/18 is equivalent to 5/9, so on and so forth. Now we have our common denominator. We're going to keep it, and be careful with your signs. We have a negative 10 minus 12 plus 3. So if we go across the top, we have negative 10 minus 12 is negative 22. Then negative 22 plus 3 leaves us with negative 19 over 18. Let's double check this on the calculator. And to save time, I just typed it all in myself, and you see that we got the same answer, negative 19 over 18. So we're going to do one more example here. I know this video is getting a little bit long, but it's worthwhile if it helps us understand how to add and subtract fractions. So once again, we're looking at, in this example of adding and subtracting a bunch of fractions. Let's go ahead and go through the process of finding an LCD. We write down the denominators 3, 4, 8, and 9. Let's clean that up just a little bit. And now I'm going to use the repeated division method. I just wrote down once again all of my denominators. I'm going to start with 2. 2 does not divide into 3 evenly, so I bring it down. 2 divides into 4 twice. 2 divides into 8 4 times. 2 does not divide into 9, so I just bring it down. I can use 2 again. 2 does not divide into 3. It does divide into 2 one time, so that column is done. 2 divides into 4 twice. 2 does not divide into 9, so I just bring it down. I can use 2 again. It doesn't divide into 3. The one column is done. 2 divides into 2 once. Now that column is done. 2 does not divide into 9, so I just bring it down. So I can use 3 again. Or not 3 again, 3 for the first time. 3 divides into 3 once. Now that column is done. 3 divides into 9 3 times. Now I use 3 again. Oh, I shouldn't have circled that 3 over there. Let's try that again. It divides into 9 3 times. And now 3 divides into 3 once. So now we're done. So if we multiply all these numbers together, 2 times 2 times 2 times 3 times 3, you'll see that that does give us an LCD of 72. So what we're going to do here is write this problem down again, and we're going to rewrite it using the LCD in just a minute. So change the double signs that match to a plus, that don't match to a minus, and that last fraction was not a double sign, so we just bring it down. Now just rewrite the fractions with the LCD of 72. Bringing down the operations that we have there. So what we're going to do is divide. 3 goes into 72. That's going to be 24 times. So I need to take 24 times 2, which is 48. 4 goes into 72. 18 times 3, 54. 8 goes into 72 9 times. 9 times 6 is 54. And then 9 divides into 72 8 times 1, which is 8. And I made a mistake here. 9 times 7 is not 54, it's 63. So sorry about that. We're dividing again. 8 goes into 72 9 times 7 is not 54, it's 63. So anyway, now that we have the LCD, we're just going to keep the LCD, which is 72, and add and subtract the numerators. 48 plus 54 minus 63 minus 8. And if you do that, that's equal to 31 over 72. So that's reduced. Let me go ahead and double check that on the calculator. And you can see I get the same answer. So, you know, I made a little mistake myself here in the multiplication here. I figured that out when I looked at it. I'm like, well, something's not right here. But just be careful when you do the arithmetic. Anyway, the final answer here is 31 over 72. And I hope this helps you understand better how to add and subtract fractions.